the last kind of thing we need to do in terms of being able to factor different types of polynomials is factoring what's called the sum and difference of cubes. Before I start to dive into this, these are all the other things we've factored up to this point, and we've done every single one of these factoring methods. Okay, we factored out GCFs. You've heard me say always start with that so many times in this class. So continue to look for GCFs. Quadratic trinomials, how we factor them. We had a whole unit on that. We've already practiced that this semester as well. Perfect square trinomials, just a subset of those quadratic trinomials. We factor those the same way. Difference of squares, that's the one that a lot of you tend to get confused by because that middle term is missing. But again, we've talked about those. And lastly, factor by grouping. That's what we spent a lot of last week doing, was the factor by grouping. When we have 4 terms already, and it's jumping straight into it. So today, we're going to factor what's called a sum or difference of cubes. And this is important because if we try to find solutions to these problems, the factoring piece has to happen. We don't really have another method of being able to obtain solutions when we get equations that are in the form of being a sum of cubes or a difference of cubes. Okay, and I'll talk about how we're going to go about doing that already. Now, the first thing I'm going to ask you to do, and some of you did this on Friday because we did at least talk about this, but that needs to get written down because how we factor the sum and difference of cubes, it literally is just plugging into a formula. So the hardest part is recognizing that we have sum or difference of cubes. And then after that, we're just substituting different values into the formula. Okay, so that formula absolutely needs to get written down. And one thing that I had mentioned, and this is how, for those of you that were here on Friday and already took this note, the one thing that I said to help us remember the formula, because for the most part, it's the same whether or not I have a addition or a sum of cubes or the subtraction or the difference of cubes, right? That first factor here has a value of A and a value of B. What's different is the sign. So what I described as a way to help us keep track of the signs in this formula, because that's what's different, whether or not it is sum or difference, is the acronym SOAP. Okay, so the S saying same sign as what we started out with. So if we're adding, that first sign is also adding. If we're subtracting, that first sign is also subtracting. Then in the second factor, we get a quadratic where we're going to always have that a squared term. And the sign that comes after that is going to be opposite from where we started. So if we were adding cubes, then that second sign is negative. If we are subtracting cubes, that second sign is positive. The middle term is always A times B. And the final term, the sign of it is always positive. That's how we finish the acronym of SOAP. So AP for always positive. And that value is B squared. Okay, so for now, this is a formula I want us to memorize. Okay, and again, there's not a huge difference between whether or not we're summing the cubes or subtracting the cubes. Okay, it's just a matter of what the signs end up working out to be. So the hardest part, and this is a lot of kind of what we've talked about this year, is the recognition. How when you see this formula or this equation on an assignment, especially when I start mixing in all the different factoring techniques, how do we know that this is a sum of cubes or a difference of cubes? Well, the key part of that is the cubes, okay, meaning a number that is a perfect cube. So some number or some integer times itself 3 times. So I also have a list of all these cubes on this note page here. I can also put these up on the whiteboard, as this is kind of what we need to focus on recognizing as we work through the factoring and then eventually the solving today. Okay, so remember with cubes, we're thinking about what number times itself 3 times gets us to these specific values. So 2 cubed is 8 because 2 times 2 is 8. Now the last thing that I also want us to remember is that a perfect cube can be negative, right? With perfect squares, we can't have negatives because I can't take square roots of negatives. But with cubes, because we're adding in that third term, if I had like -3 cubed, well, 3 cubed is 27, but making that negative, I am going to get a negative 27, as opposed to when we square values, it's always positive. Okay, but when we're cubing, we are opening up our numbers we can get to being negative as well. All right, so I just want to mention that before we jump into the factoring part. And so now let's do the factoring part. And so again, the first thing that we need to do is recognize. So one way that gives us away is we're going to see a cubed. Okay, we're going to see like an x cubed or some variable to the power of 3. So that should be your first kind of indicator that this is a sum of cubes or a difference of cubes. The other indicator is that there's only two terms, right? This is only x cubed plus some number or 108x cubed minus some number. So seeing the variable to the power of 3 and then the two terms is what gives this away. The first thing that we need to do is identify our values of a and b. Okay, and that's where this is probably unique to anything we've done thus far. So how we're going to do that is we need to take each term, the x cubed and the 27, and we need to write it as something to the power of 3. That x cubed is basically already in that format. But one thing I want to do to make it kind of consistent for when we get to other polynomials that need to be factored is take the original term and just rewrite it. And we're going to rewrite it by taking the cube root of the coefficient. So the coefficient here is 1. And the cube root of 1 is just 1. So I'm going to take the cube root of that, which is just 1. And then this x, I'm going to include with that coefficient. I'm going to put all that in parentheses. And I'm going to say that that term, the 1x to the power of 3, that is equal to this x cubed. And this tells me that a is equal to 1x. Okay, so at least in this case, that x cubed doesn't make a big difference here. But now for the 27, instead of thinking about it as 27, instead, I'm going to think about it as what number to the power of 3 is 27. And that would be 3. So 3 cubed is equal to 27. This allows me to now identify the value of b being whatever number is being cubed there, which is 3 in this case. So as soon as we can pick up what a and b are, now it's just a matter of substituting these values into the formula. Okay, so the two hardest parts that you all will run into issues with. Number one, the recognition that we have some difference of cubes. After that, it's identifying what the value of a and b are. And remember, it's not going to be just what we see in the equation. Okay, but once we have a and b, now we're just going to take the equation, since this is sum of cubes, it would be a plus b times a squared minus ab plus b squared. Okay, so same sign as where we started, opposite sign from where I started, and then always positive at the end. And now I'm just substituting these terms back into that formula. Okay. One thing I will do is use parentheses, especially in the second set because of the squaring and because of the a times b. So a plus b in this case is 1x plus 3. I don't need to add in any additional parentheses there. If you want to keep that consistent, just so you're always doing things the same, that's fine. We don't need additional parentheses there. But for the next term, because we're taking that value of a and squaring it, I am going to use parentheses there. So that's 1x squared, and then minus a, which is 1x, times b, which is 3. And again, those parentheses are going to help me keep track of what I'm going to do with those two terms. We're going to multiply. And then plus b squared, which is 3 squared, so 9. And so the only thing that we need to do from here is simplify these terms. And that's, again, where the parentheses really help us with what we need to do to simplify it. So 1x, instead of writing 1x, I'm just going to write that as x plus 3. The 1x squared, well, that's 1x times another 1x, which is just 1 squared x squared, which is just x squared. 1x times 3 is 3x, so minus 3x, and then plus 3 squared, which is 9. So what this means, or what we just did, is we took that equation of x cubed plus 27, and we factored it into these two terms, x plus 3 times x squared minus 3x plus 9. And that is what would allow us to then find the three solutions that show up in that polynomial. And that's what we're going to actually do here in just a moment. Okay, so to me, this one's a little bit easier because that value in front of x cubed being 1. So let's work on number 2 together. And then, and we're going to actually extend this into us solving these polynomials here in just a moment. So let's kind of start the whole thought process over again. And we're going to factor 108 x cubed minus 32. And again, I'll talk you through my exact thought process with these. Okay, so the first thing is I want to recognize, is this a sum or difference of cubes? Right away, I see this x cubed. So that probably is telling me this is a sum or difference of cubes. I'm also noticing that I only have two terms. The problem I'm running into is I don't recognize 108 or 32 as being perfect cubes. And if I check this list, we want those numbers or those coefficients to show up on this list. I don't see a 108 or I don't see a 32. So I'm like, okay, it's a little odd, but I remember that Mr. Youngren has emphasized to look for greatest common factors. What number divides 108 and 32? I think there's actually quite a few. 6. The 6. Yeah, I think 6 works. Let's divide 6. Let's see what we get. Actually, 6 does not divide 32. And not 6. What about 8? I don't think 8 goes into 108. Let's think smaller. They're both even. So we can definitely divide out a 2, right? Let's start with a 2. So dividing all those by 2 gives me 54x cubed minus 16. I'm like, okay, do I see those in my perfect cubes? Not quite yet. I'm not seeing 54 or 16 in this list. So that means there's probably still another number that divides these terms. How about another 2? Right? So I could take out another 2, which makes this a 4. Those terms would multiply. And this is 27x cubed minus 8. Okay, so really that GCF was 4. That was the number we were looking for there. And by taking out the 4, well, now I recognize 27 as being a perfect cube, and I recognize 8 as being a perfect cube. Okay, so that's a little more advanced, right? We still have to look for a GCF, and then we have to recognize the cube numbers there. Just like before, our next task is to figure out what the values of the A and B term are going to be. And that always comes from us basically taking the cube root of the coefficients and rewriting them. So 27, that is equal to 3 cubed. So I'm going to rewrite 27x cubed as 3x to the power of 3. And this tells me that the value of A is 3x. 8 I recognize as being 2 cubed, okay, or the cube root of 8 is 2. So I'm going to rewrite that as 2 to the power of 3. This allows me to identify the value of B as being 2. So again, that is the hardest part, the recognition and the identifying of A and B. Now it's just a matter of us plugging in all of these terms in the right place. So since this is a difference of cubes, meaning we're subtracting, this is going to be A minus B times A squared plus AB plus B squared. And we just need to substitute all these values in and then simplify. So A minus B, that's 3x minus 2. Then I have 3x squared plus 3x times 2. And then plus 2 squared. And then the simplifying part there, 3x minus 2, 3x squared, the 3 and the x get squared, so that's 9x squared. And then plus 6x and plus 4. And that is equal, well, especially if we throw in the GCF of 4, to the 108 x cubed minus 32. All right. Any questions that we're seeing? Okay, any places that we're like, I feel like that part's kind of tricky. Casper, what do you got? Okay, so good question. Why? So because we're using the difference of cubes form or difference of cubes equation or that formula, our values of a and b will always be positive. Okay, now one thing that you could have done is you could simply just memorize the sum of cubes formula and then make that term negative, and that'll, when you plug that into the positive, the sum formula, that'd take care of your signs there. Okay, so really for us to kind of keep things consistent and use these two formulas, when you identify your values of a and b, it'll always be positive. That negative is just telling me to use the difference formula as opposed to the sum formula. Does that make sense? Okay, and that's one thing that we'll all have to work on are the signs. Okay, but when identifying a and b, just make them both positive and then either use the sum formula or the difference formula based on where you start. Okay, well, I've already done a lot of talking. You have, ooh, dang it. I want you all to do one, so let me pull up a different one, and we're going to actually extend this and set these equal to 0. So give me 1 second. Let's not do these, because I already did the factoring there. I want you all to practice the factoring. And we'll do both the sum and the difference. So give me 1 second so I can. So we're going to roll with these two. Okay, and I want you to factor these two in your groups and only factor these two in your groups. And remember to look for GCFs, then work on identifying A and B, and that's the main thing you should be doing in your groups. What is the value of A? What is the value of B? We will go over the factoring together, and then we're going to do one more thing with these before I get you going on any sort of homework, okay? All right. Number one, right off the bat, again, I see that x cubed. I see the 125 and 1, which I recognize as both numbers being perfect cubes. Again, if you don't know perfect cubes, make the list. Okay, I have them on the board, but that's an easy list that you all can make on your paper when you're taking a quiz or when you're taking a test. Just take all the whole numbers, like 1, 2, 3, 4, etc., and then just multiply them by themselves 3 times. The numbers you get from that are your perfect cubes. Okay, so 125 is a perfect cube. 1 is also a perfect cube. For me to identify the values of A and B, again, it's me taking the cube root of each of those terms. Cube root of 125 is 5. Cube root of 1 is just 1. So this allows me to identify that A is 5x and B is 1. Then from there, just substituting everything into the formula. Nothing extra that we need to do there. All right, but now for number 2. I look at that, and right away, the 2 throws me off, because I'm like, the 2 is not a perfect cube. And I don't think 250 is a perfect cube either. So I'm like, okay, that probably means there's a GCF, right? And the GCF here is 2. I can divide both those numbers by 2, resulting in a 1x cubed, which allows that to be a perfect cube, and then 125, which is also a perfect cube. Okay, so that GCF of 2 has to get factored out. Now, a good question that somebody asked was, when we take out a GCF, what happens if these numbers aren't perfect cubes? Well, then we can't factor it this way. Then we're left with another way of how we need to come up with these solutions, which that's what we're going to work on next week, basically. Okay, so it should always result in perfect cubes. Otherwise, it doesn't factor the way I'm explaining it today. So then that allows me to identify A as 1x, B as 5. Now I'm just substituting everything into the difference formula and then solving from there. or simplifying from there. Okay, now one extra thing that you're going to have to do on the homework, and again, we'll work on this in class tomorrow, but let's pretend that instead of it saying just factor, I do this. What changes now? Am I done? What needs to happen next? If I take an equation and I set it equal to 0 and I factor it, it means I want to come up with the solutions. But what am I going to do with each one of these factors to come up with those solutions? Someone help me out. When we factor, how do we get solutions? What do we do to each individual factor? Set the whole factor equal to 0. So that's what would need to happen after this. So let's pretend that happened. Okay, it was equal to 0. We factored. So now I take each factored term, set it equal to 0. Set it equal to 0. Well, this first factor I can solve really easily, right? I would subtract 1, and I get x equals negative 1/5. Well, there's one of my solutions. How many solutions in total is this equation going to have? How about we do this? How about we put up on our hands how many solutions it's going to have? It's going to have 1 solution, 2 solution, 3, 4, 5, 6. Few of you, give me some answers here. How many solutions? I see a 2. I see a 3. Thank you for the 7 of you that are willing to answer. There should be 3 solutions. How do we know this? The degree is 3, right? That is something we emphasized in the lessons last week. The highest degree, or the degree, tells us how many solutions. Well, I've only got 1. The other 2 solutions come from this equation right here. Well, we factored, but is this factorable? Can I get my solutions from this? Not from factoring this. After you do the initial factoring, you get your last 2 solutions from quad formula. And whenever we use this sum or difference of cubes formula, you will always need to use the quad formula to find the solutions. Okay, so just a reminder that the quad formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. You will have to do that every time you solve a difference or sum of cubes formula. Because we're going to run out of time, I'm not going to do that quad formula piece, but it will be a part of your homework. This is also something we can talk about at the start of class tomorrow.